Hi students, in this video I'll be going through the JYSS 4E Additional Mathematics Mid-Year Exam 2010 Paper 2 Question 10, right? So let's read the question. So a cylinder of radius r cm is placed inside a circular cone of radius 12 cm and height 20 cm. So that its base level is level with the base of the cone as shown in the diagram. Okay, show that the volume of the cylinder V cm³ is given by this equation. Okay, so over here we are told that this cylinder has a radius of r cm. Okay, so they didn't label it here, but we can actually label in the diagram on our own. So over here we have the radius r. All right. So we know that the formula for the volume of cylinder. So you need to know some formulas for different solids such as cylinders, spheres, and cones and so on. Okay, so we know that the volume of a cylinder is base area times height. So pi, now the radius is r, so r square. Okay, the height it didn't give us, but we can always label it on our own. So we can call this height of the cylinder to be h, right? So this will be h. Okay, so pi r square h. Okay, but if you look at the formula that they gave us, okay, it doesn't have any h there. Okay, so in other words, we will need to formulate an equation that relates h and r, and then we sub into this equation to substitute away the h. Okay, so I'll call this equation 1 first, and then we'll go about trying to find the h. Okay, so whenever you see a question that involves a cone, okay, you've got to start thinking about similar triangles, right? So you've got to start thinking about similar triangles. Okay, so actually this h, actually I've drawn it slightly further. Okay, so the cone, if there's a base over here, okay, so the h will be all the way from here to over here. Okay, so which similar triangle are we looking at? So whenever you have cone, the similar triangles that you want to look at would be this smaller triangle below. Okay, so this triangle below is a right angle triangle, and the bigger one on top. Okay, this one. Okay, so you can see that these two triangles are similar. The big one this way is similar to the small one this way. Okay, so this will enable us to form an equation involving h and r. Then we will be able to substitute away the h. Okay, so the height of the cylinder is h. Okay, so from here, this point, all the way to the bottom of the cone, this will be 20 minus h, right? Because 20 is the full height of the cone, minus away the height of the cylinder, then we will get this one, okay, to be 20 minus h, right? Okay, this one will still be r, okay, still the base radius of the base of the cylinder. All right, so now we're going to use the property about similar triangles that ratio of corresponding sides are equal. Okay, so the ratio of corresponding sides are equal. Okay, so r, okay, this radius over here, this side will correspond to the 12, right? Okay, for the big triangle. So we will have r over 12, which will be equals to 20 minus h over the full height, which is 20. Okay, so we'll get this. Okay, then all we need to do now is to do some cross multiplication. So this one cross up, this one cross up. So we'll get 20r equals to 12 times 20 minus h. Okay, so we'll get 20r equals to 240 minus 12h, right? Okay, so now we're going to make h the subject, and then we will substitute it away. Then the full equation for v will be in terms of r already. Okay, so we'll bring the 12h over, then get 240 minus 20r. Then we'll divide by 12. Okay, so when we divide by 12, we will get 240 over 12 will give us 20. 20 over 12 will be 5 over 3. Okay, so we'll get this. Okay, so we'll sub equation 2 into equation 1, and we should be able to show that what they want us to show, right? Okay, so substitute 2 into 1, right? So we will get v equals to pi r square. H will be 20 minus 5 over 3r. Okay, so what they want is 5 over 3 pi, right? So we're going to bring the r inside and factorize out 5 over 3. Okay, so let's factorize out the 5 over 3 first. Okay, 5 over 3 pi r squared. Okay, so you got to ask yourself one question now. What times 5 over 3 will give me 20? Okay, so you should realize that it will be 12. Okay, actually, you can just take the clue from here. There's a 12 here. Okay, so you can test out 12 times 5 over 3. So cancel 3 cancel with the 12 becomes 4. 5 times 4 will give you the 20. Okay, if you're taken out 5 over 3, then here will just be negative r. Okay, then we'll just multiply the r squared inside and we'll be able to show it. So 5 over 3 pi 12r squared minus r cubed. Okay, so show already. Okay, so not too difficult. So as long as you always see a cone, you should always be thinking of using similar triangles to get a relationship between r and h. Okay, then you can always sub away the h. So the key thing here is always to write out the essential formula first. Volume of cylinder is base area times height, pi r squared h, and then you work from there. Okay, try to substitute away the h. Right? Okay, part 2. Okay, they want us to find the value of r such that the volume of the cylinder has a stationary value. Okay, so now the volume has a stationary value. So we know that when volume has stationary value, then dV dr is going to be equals to 0. Okay, then they want us to determine whether this value is a maximum or a minimum. Okay, so V is equals to 5 over 3 pi 12r squared minus r cubed. Okay, so to differentiate this, it will be better to expand it out. Okay, then you do the differentiation, or actually we can straight away differentiate from here. Okay, so from here we can do a dV dr. Okay, so we'll just leave the 5 over 3 pi outside, then we'll differentiate this one. Okay, so differentiating 12r squared, you will get 24r. Okay, minus differentiating 3 r cubed, you will get 3r squared. Okay, so this will be the answer. Okay, so at the stationary value, dV dr will be equals to 0. So at stationary value, okay, at stationary V now, okay, volume, dV over dr is equals to 0. Okay, so 5 over 3 pi times 24r minus 3r squared will be equal to 0. Okay, 5 over 3 pi can't be 0, so it will just be 24r minus 3r squared equals to 0. Okay, from here, we'll factorize out 3r. So here will just be 8 minus r equals to 0. So it's either 3r equal to 0 or 8 minus r equal to 0. From here, you'll get r equals to 0. Okay, which is not possible, right? So you got to reject this answer, okay? Because if radius is 0, then you do not even have any cylinder to talk about. So over here, you get r equals to 8, right? So this is the r that we want. Okay, find the value of r. Okay, then they want us to determine whether it's maximum or minimum. Okay, so for this, you will need to either use the first derivative test or the second derivative test. But if you look at this particular dV dr, it's actually quite easy to differentiate one more time. So I think it will be better to use the second derivative test. Okay, so let's use second derivative test. So d2v over dr squared will be 5 over 3 pi. Okay, differentiating 24r, you get 24 minus differentiating 3r squared, you will get 6r. Okay, so we just sub r equal to 8 inside and then we'll do the calculation. Okay, so when r equals to 8, d2v over dr squared equals to 5 over 3 pi 24 minus 6 times 8. Okay, so you will get 24 6 minus okay, if you do the calculation, you should get negative 40 pi lah. Okay, for this, right? Let me do a calculation. 24 minus 48 times 5 over 3. Yeah, so negative 40 pi. Okay, so d2v, the r square is a negative value. So it shows that when r is 8, the volume will be a maximum. Alright. Okay, so let's just conclude over here. So since d2v over the r square is less than 0, when r equals to 8 dm, V will be a maximum, right? Okay, so not too difficult for this question. Okay, let's take a look at the last part. So the last part involves a rate of change question, right? So you can see from this question, it involves both maxima and minima problems as well as a rate of change question. Okay, find the rate of change of V. So they want us to find dV dt. Okay, so always summarize the whole question in one statement. Find dV dt. Then write down what is the info that they give us. When rate of change of radius is 1, when dr dt equals to 1 cm per second, and r equals to 2.5 cm, right? Okay, so find this, okay? Okay, so let's write out the connected equation. So the first step, always summarize. Second step, write out connected equation. So the thing that you want to find, always put on the left side. Okay, so dV dt equals to dr over dt times dV over dr. Okay, so the thing that we need to put inside here is dV over dr. But actually, we have already gotten dV over dr from this one, right? Okay, so we can just directly put it inside. Okay, so 24r. Okay, so let's write down first. Okay, dV dr, this will be 1 cm per second times. Okay, so this one over here, we have 5 over 3, 24r, 5 over 3 pi, then 24r minus 3r square, right? Okay, minus 3r square, minus 2.5 square. Okay, so just sub the r from here inside here. Okay, so if you do the calculation, you should be able to get this answer. Or if you want to live in 3 sigma, then 216 centimeter cube per second. Right, so both answers are actually fine. Right, so overall, still quite a manageable question. Okay, you just need to do a bit more practice, and you should be very familiar with solving questions like this, right?